The first formula is if it tells you that you're rotating on the y-axis. That's what the y-axis is there for. The second formula is if you're rotating about the x-axis. Okay? Now, what I have learned is that you actually can do this always in x's, even if you're rotating on the y-axis. Okay? So what happens is, if you're rotating on the x-axis, you actually can put in the equation for y where y stands for. So like if y was x squared, you could put x squared right here because x squared is y. Okay? If you're rotating on the y-axis, you really do just put x. Okay? So you actually can do surface area all in x's, no matter which one you rotate about. The only thing that changes is what you put where the radius is. This x and y stands for the radius. Okay? And so if you're doing it on the y-axis, you put x. But if you're going around the x-axis, you actually put the equation for whatever y equals. So anyway, you can put the equation for y here and do it all in x's, which means dx if you want to. Okay? So we'll do some problems and I'll show you how that will work. So let's say that we have this graph. This is y equals square root of x, and x equals 4, and x equals 9. These values are 2 and 3. And this thing is kind of like if you rotated it about, so let's see, where we're going to go around. We're going to go around the x-axis. So this thing is kind of like a donut without the middle cut out of it, sort of. And when we say surface area, we're trying to find the area of the outside of that thing. We're trying to find the area of what makes it up. Okay? And this formula helps you do that. So, if we just want to keep with x's and not even worry about the y's, let's just do that. Okay? So, if we're going to do that, where would the integral be? From where to where? 4 to 9. Okay, because you're going around the x-axis, the radius is y. But what is y? Square root of x. Okay, and then it says times the arc length. Arc length is the formula that you learned in the arc length video, which is square root 1 plus the derivative of whatever the equation is. So the derivative of square root of x is 1/2 x is a negative 1/2 squared. Yes, there is a 2 pi. That's part of the formula. Good. So it's 81.1 or 1 or 2. Okay, let's do another one. So this time, let's do this one. Well, really you won't be looking at this part of it because that part will be the part that's being rotated. But we're going to rotate it around the y-axis. And we're going to go from 0 to square root of 2, which means that the y value is at 2 if you need it. Okay? And it's this region that's connecting to the x-axis, the part you're rotating around, which is the region that matters. Okay, so on the previous problem, you were going around the x-axis, right? And so when you went around the x-axis, this part was y, or the equation of y. Okay? Because we're going around the y-axis, the first part of it is x. Okay? And then times the arc length. So square root 1 plus... Oh, it's y equals x squared. Sorry.
That's why I was confused.
And then the derivative squared. And from where to where? What would the values be on the integral? 0 to square root of 2, right? Because we're in x's. You should get 13.614. Okay, last one. This time, let's say that we have y equals x to the third. And it's going from 0 to 1. Again, if we graph it, it looks like this. And the x-axis would be part of your boundary. We're going to go around the x-axis this time. So this is one of those cone things, sort of, with no hole. Alright, so we have the integral from 0 to 1, 2 pi. You said the equation, so x to the third. Square root 1 plus the derivative of the equation. And if you work that out, you should get 3.563.